We are going to look at the convergence of series of the form 1 over n to the p, and that's sometimes called p series. And we are going to see that for some values of p, the result that we obtain about the convergence of those series, it's based on the application of the integral test. But let's begin with the actually easier cases. Let's say that we are talking about p less or equal than 0. So the associated sequence is 1 over n to the p, and we want to classify the associated series. Well, actually, in this case, we can just apply the n-term divergence test to see that those series diverge. To apply the test, what we need to do is look at the limit of 1 over n to the p when n approaches infinity. Well, let's say that p is equal to 0. Then in that case, it's just the limit of 1, which is not 0. So it diverges. And if p is strictly less than 0, then the limit is infinity, which is not 0 either. So since the associated sequence has limit that is not 0, we can conclude the divergence of the series by the n-term divergence test. If p is greater than 0, now is when we want to apply the integral test. So let's look at the function that is 1 over x to the power of p, or p positive value. This function, and we consider this function for x greater or equal than 1. We don't care about what happens before. This function is continuous. It's also decreasing. And it's positive for all the values we're considering. And this is the sequence that this is the function is that if we consider only the images of the natural terms, we'll get the sequence we are trying to work with. So by the integral test, what we can conclude is that the series converges if and only if the improper integral converges. 1 over x to the p dx converges. And here we are summing from 1 to infinity. So this is what we obtain from the integral test. But about the improper integral, we saw in class, we worked with this in class, we saw that for p less or equal than 1, the improper integral is actually divergent. So the associated series is also divergent. So p less or equal than 1 diverges, and for p greater than 1 converges. So we consider all the values of p. We conclude that the p series 1 over n to the power of p summing from n equals 1 has the following behavior. If we are considering p to be less or equal than 1, then it diverges. And if we are considering p to be greater than 1, then it converges. And that's what we call the p-series test.